Hi everyone, welcome back. In this video, we're going to talk about multi-spring system. So when we talk about multi-spring system in physics, we usually talk about two different scenarios. So the first one is as illustrated on the left side, which is called parallel. So the two strings are arranged in a parallel way, attached to a mass at the bottom. And the second configuration is as illustrated on the right, which is called series, where two strings are attached one by one like this vertically and also attached to a mass at the bottom. So we will explore these two and their respective equivalent spring constants formula and their derivation. So as we learned before, or potentially learned before, Hooke's law says F is equal to negative kx, where F is the spring force, k is the spring constant, and x is the stretched length. So in this investigation in this video, we will just drop this negative sign and say F is equal to kx. So let's look at the first scenario, which is the parallel configuration, where two strings are arranged in a parallel way and attached to a mass at the bottom. So as we can see that both of these springs experience a downward gravitational force, and each of the spring will stretch for a distance of x, and this x will be the same for both of these springs, and it will also be the total stretch of the system. So if we call this spring 1 and this spring 2, we will see that x1 is equal to x2 is equal to x total, or we say x equivalent. So then we will see that for on each spring, we will experience a downward force. And taking them together, if we sum these two forces up, we should get the total downward gravitational force. Therefore, we will have F1 plus F2 is equal to F total, or we will say F equivalent. And as we know that since F is equal to Kx, we will say K1 x1 plus K2 x2 is equal to K equivalent x equivalent. And the key here is that since we already said x1 is equal to x2 is equal to x equivalent, we can simply cancel out the x terms or the stretched length terms. So we will have k1 plus k2 is equal to k equivalent. So this would be the formula for a parallel spring system. Excuse me. And next we will explore the series spring system, where two springs are attached top to bottom vertically and attached to some mass at the bottom. So we need to recognize that for this case, each of the spring also experiences a downward force, and each of these forces is equal to the force experienced by the whole system, which is the gravitational force associated with the bottom mass. So if we call this spring 1, the spring 2, we can see that F1 is equal to F2, and it's equal to Fg, and it's equal to F total, or F equivalent. And then we will see that Kf1, and we will see that for each spring, it will stretch for a distance. This is x1, this is x2, and the total stretch of the system will simply be x1 plus x2. So we will say x1 plus x2 is equal to x equivalent. And since we already said for Hooke's law, F is equal to kx, then x will be equal to F over k. So if we rearrange this, we will have F1 over K1 plus F2 over K2 is equal to F equivalent over K equivalent. And as we stated before, F1 is equal to F2 is equal to F equivalent, then we can cancel out these three terms. We will have 1 over K1 plus 1 over K2 is equal to 1 over K equivalent. So this would be the formula that could be used to determine the equivalent spring coefficient for a series multi-spring system. So these are the derivations of these two very important formulas for the two multi-spring systems. Thank you for watching.